Hey everyone, welcome to the Data Forge. I'm your host, David No, and today we have a very special um, episode for you because we have two guests. My fearless co host, Ken Morimoto, is here, as well as Mahesh Good is here, and we're really excited to have you. How you guys doing?
Doing awesome. Happy Friday.
Yes. Happy Friday. How you doing, Mahesh?
Yeah, I'm doing well. How are you all?
Yeah, we're doing good. Good. Great to have you, and thanks for coming.
Thanks for inviting.
Now, Mahesh, you are an applied AI scientist or applied. What's your what do you do? What's your title, first of all?
Right. I'm applied scientist at Amazon, working in devices org, but things vary a lot. From a work perspective, it goes from modeling to data curation to infrastructure related aspects. It's diverse, but at the end of the day, trying to meet the customer needs for next generation products.
So tell us a little bit about how you came into this field. Maybe start from where you're from and how you came into AI.
Right. It's been a long journey. Like at this point, working in the AI field for a little over a decade. I'm from India, Hyderabad, South India in particular. Uh, what brought me into the AI field was the theory behind machine learning algorithms in particular. My undergrad university had a research program back then, like in the second year of undergrad, and entered into the computer vision field. Thought the learning algorithms were really interesting. My first algorithm happened to be like Adabos learning algorithm, trying to make sense, like how is it working? How is it iteratively minimizing the loss, all the interesting aspects. But beyond that, uh, so I was more leaning, happened to have an inclination towards theoretical ML. But as time went along, I moved to I came now to the United States for my master's program. Had a couple of PhD opportunities at different places. I was asking myself, is it the right thing for me? But I tried to move more towards the applied side of things. And then after my master's at USC, I joined like a company called Ticketmaster. Was working on like that various data science problems over there in ad space, in fraud space, and joined Amazon later, closing in on like 5 years at Amazon. At this point, got an opportunity to work on like retail commerce side of things, some certain pricing problems and certain futuristic problems as part of Amazon devices.
Awesome. And I'm curious, Mahesh. I always love to think about, you know, people's journeys, and it's a lot of it's nature and nurture, right? Like you don't choose your parents, you don't choose where you grew up. And tell me more about like your parents. Like, what do they do? How do they impact your upbringing? Like, how do you get so passionate about technology? Like, do you remember the age? Like, I always love to hear the
Right.
genesis story.
Yeah, my parents, both of them are engineers in their own way. Mom is a civil engineer, dad is an electrical engineer. They their careers span like 30 years, 30 to 40 years, which is pretty much unconventional, like in current days. They always dreamt big, at least. Dreamt big in terms of what they wanted to do. Mom used to think about like people building great dams, which is not most of
Wow.
the civil engineers do today. Uh, Dad used to think about like, oh, solar electrification of like various states in within India. Like, how do you go there from where we are? Like, power transmission by nature is lossy power transmission. Like, how can you shift to renewable? Like, what's the right power distribution model? Building substations, like next generation version of their respective fields. All they always just think about that. But beyond that, it's been like a balance of vision plus current day coolness more around. Uh, I used to be like an outdoor sports guy, so it's a mix of
Mhm.
those things. There's always this big vision, but question is like, what is it leading towards? At the same time, there are internal inclinations on, oh, what is this seal of machine learning doing? Like, how are things improving? What are its applications? So it's a mix of both that influenced my journey so far.
Yeah, interesting. Wow, what an amazing influence to have, right? Two parents who are, very accomplished engineers to spark the curiosity, and so I can see why you're a, applied scientist. So thanks for sharing that.
Did they pressure you in any way or push you in any way to do one field or another, or did they just encourage you to do whatever you felt passionate about?
Who pretty much encouraged me to do whatever I feel passionate about. And I think I would say uh, naturally the inclination grew towards maths. Naturally, the inclination grew towards, as my undergrad happened to be in computer science, inclination grew towards how are these scalable systems working. It just happened along the way. And by the way, my sister, again, I think she entered like computer science field. She was continuing the same field. I think it just happened organically.
I see.
They led by example, pretty much.
I'm curious, up to
Yeah.
this date, what is the biggest challenge that you had to overcome, personal or professionally, to this date? Like, do you have any? Can you share one of the biggest challenges that you felt you had to overcome in your journey?
So on the professional front, uh, the biggest things are like whether to do a PhD or not. Like I had like along the way, I had like two PhD opportunities so far. Once in Europe, once in around USC after I completed my master's. Like whether to do it or not, is it the right thing for me? There's one aspect of me who was a theoretical ML researcher. Like if real world didn't come in its way, like I would have been a theoretical ML researcher. Uh, but there's another aspect of like scalability. What's the impact the systems are creating? How is it impacting the society? Like there are always good and bad sides of idea.
Hmm.
Like what are the larger implications? Like that brought me to a balance of these two. So the professionals friend, I can say the challenging situations are like one is deciding that. Like, and I happen to say, at least to myself, I answered no for the two times.
Why is that? I mean, getting a PhD opportunity at USC is, I mean, it's most people dream of that opportunity, right, to get in. And why
One,
decide against it?
right. So at that, to me, it's this big vision versus what is the outcome of my PhD. That's always the thing. And at
Hmm.
USC, my PhD topic seems to be going around like forecasting models, like a certain version, like next generation forecasting models. At that point, deep learning is kicking off, like around 2015. Yeah, now certain state space models, like how do you best develop like new generation deep learning models. It's a good topic. For sure, it's a good topic. But when I ask myself the question, like X years from now, 3 years to 5 years from now, if, if I didn't do this PhD, like would my PhD make a difference, either to me personally or to the field? The answer was no, because I'm more of a generalist guy, as I just mentioned. I want to see the impact of machine learning algorithms, systems, scalable things on the eventual impact on society. Like to me, that's the direction I personally care more about. So yeah, my answer came out to be no when I asked myself.
Interesting. So where do you see the biggest impact that AI and machine learning can solve for our human species? Like, for me, like I can see medical, like describing new drugs, cancer diagnosis, a lot of med tech, I mean, there's so many use cases, right?
Right, right,
What are you most passionate about?
right. The way I see it is like every decade there's a field which dominates, right?
Hmm.
So just as I explained my own parents, like there was a decade when power systems was a big thing. There was a big decade when building dams was a great, all right, human civilization. Like last decade happened to be like search systems, like mobile application
Hmm.
related to system, and as a natural consequence came like search, retrieval, ranking problems for a number of applications. So every decade defines itself. This decade seems to be like it's entering a new territory of like all this multimodal LLMs, power
Hmm.
like reality experiences, robotics, previously unrealized settings where we are able to realize them now. So this decade, I think we'll see a lot more aspects around augmented reality applications, new charting new territories around robotics applications, which was already the case before, but I think we'll see the next cusp of innovation.
Yeah, I mean, the multimodal, like the humanoids actually, for me, I've been always kind of a skeptic, right? But now I've seen some videos, right, from Tesla to, I mean, been a bunch of funding, right? Figure,
Yeah,
I've seen some videos of some Chinese robotics companies, and I'm sure you're probably thinking this
yeah,
is just remote control. Like, is this really, um, what are your, eh, and I actually feel like that area can be quite disruptive, right? In terms of
right.
how
No,
it's going to change the workforce. I mean, what do you think? Do you think how many years do you think we're away to have a general purpose robot like humanoid doing our laundry, mowing a lawn, going to, being at the fulfillment centers, right?
right, right.
Um,
Yeah, autonomous robots, right? Like before going general purpose, at least like specific purpose robots are
yeah,
deployed.
narrow AI. Yep, yep.
Narrow AI, it's deployed today. That's a good news. At least like some specific use cases are deployed. I'm pretty sure Amazon fulfillment centers have a lot of targeted robotic devices which move inventory around. Uh,
hmm
but largely, right, like autonomous driving cars or a general purpose humanoid. I'm not, my expertise is limited in that area, but I would imagine like there are a lot of failure scenarios.
hmm
First thing is deploying something which is, we should only be deploying something which is not net negative customer. I see a lot of corner cases, aspect around safety, even if tech was perfect, like all the ironing out all these things will take a while.
hmm
But it's good to see that targeted applications exist and there's a path to general purpose application. Even if like robot, imagine a robot that doesn't do much, like to begin with, like there's limited degrees of freedom. Let's say that it moves around, talks to you, maybe answers video calls, like things like that. As long as you nail that with like a good experience, that can give you a stepping stone to add more degrees of freedom. But yeah, the risk factor is also increasing with degrees of freedom.
Yeah, part of me thinks that the current LLM architecture, right, like, is not going to be the next real kind of quantum leap, right, for general purpose,
Yeah,
robotics. It's very semantic oriented. I think, symbolic. There's like some research on symbolic AI, right, where it's like the humans, where we're looking at symbols, we're interpreting symbols more versus semantic. I don't know if you've ever thought about that potential new paradigm shift of how uh, AI right now. LLMs has sort of transformed the many different use cases, but what's next after LLMs? I don't know if you've ever thought about that.
right. There'll always be a next step for LLM, like making it more multi-model, making
Mhm,
these days, like I see this as like a compound AI system. Like if we are trying to build like an application today, like you'll put certain classical machine learning algorithms, certain LLMs, and you'll have certain factual database. Think about like with search. So you build a number of components to build an end-to-end use case.
mhm.
Um, but o- over time, yeah, there will be unification, right? There will naturally be unification of models, unification of this pipeline, which has always been the case. It's like initially you start out with like a specialized model, then you generalize, then you figure out a combination of specialized generalized models is what works best. But um, more than the specific models, like the compound systems is what is interesting to me the most. It will keep evolving. More data sets. We'll just better annotate the data sets we already have because of the compound system loop. And as a result of our data sets, as a result of our better simulation systems, the data flywheel kicks in, improves the models more, but
Mhm.
which drives the new set of use cases. Yeah, to me, like I see this like an end-to-end compound system where there'll always be a improvement flywheel.
You mentioned compound systems. Can you unpack that a little bit? What do you mean by compound systems?
At this point, one can imagine think about like LLM with some access to a memory, with access to specialized LLMs for certain purposes, all coming together to achieve a goal, right?
Mhm.
Today we talk about like RAG systems, like retrieval augmented systems and variants of it, um, which is great, but it, people are improving the context lengths, whatnot, multimodality again. Uh, Over time, the systems can auto-generate certain data sets, right? Like which will power the next generation of models. Um, so to me, the interaction between this, to interaction with the systems part, not just the models, but the systems part and the more powerful models. I'm imagining that I'm calling that as a compound system at this point. Now think about like our autonomous driving car, right? Like okay, for sure that it's not one model doing everything, right? Then you're not solving the right problem. It's like there's a
Mhm.
sensors team figuring out the right sensors fits. There's a perception team, there's a planning team, uh, like each, and there's an edge deployment team, and each component has got its own constraints. Now someone can argue like, oh, I'll put an LLM to do direct perception to action, and I'll drive the car. Might happen, uh, might not happen near future, but at least at least it's helping us to iterate to the next innovation loop, reducing the error barriers.
And that's also like on that thread of like that compound or the different components, this agentic AI, right? Where people are seeing, these autonomous agents working together as a system, right? Is that also, I mean, that's kind of where everybody, Eric Schmidt talks about, former Google CEO, that it's going to have the biggest impact, right? In terms of the next generation of AI is agentic AI, right? Is that also part of that where you have multiple autonomous agents working together for a common objective function, and each one of them has a specific, you know, um,
Right.
capability?
No, definitely. Like the compound systems can and should naturally evolve to the agentic systems, but I think there's a few more problems to iron out. It's like current systems, right? Like, oh, you have access to a number of APIs. Can you, or the end use case, can you orchestrate the right composition of these APIs to arrive at a goal? Oh, you didn't arrive at a goal. Like you trace back. Like things are happening in that space. Like test time thinking, retrace your paths, retrace your thoughts, recompose the API chain to arrive at your goal. Things are happening, but more work is required. Right? Like until that is fully solved, like compound systems is the way to go. Like at least for sensitive use cases like autonomous driving. Let's say.
Yeah,
Interesting.
you mentioned autonomous driving, and that's a case where you've got this complex system on the software side, but then you've got a very complex system on the hardware side, right?
Yeah.
It's both of these things have to come together. Um, and you mentioned in our previous conversations that you're really interested in augmented reality.
Mm.
Um, and I know that Meta came out with this new augmented reality glasses, and how do you see AI and these compound systems interacting in a form factor like augmented or AR glasses, if you will?
Yeah. So firstly, my interest in the AR specs is because it's definitely the next computing um, innovation that's about to happen. And me as a customer, right? Like it, I see a lot of value for my own self. Like India is pretty diverse. Like if I can go into different states of India and understand others' languages in real time, that would be great. If it can auto translate an image content for a different language, phenomenal. Like I would right away buy it. So for sure, it has its value. Probably started with Google Glass, then headset oriented devices didn't take off. Like probably Microsoft Hololens, Magic Leap. They have their use cases. They're great, but uh, like at some point, like who is the right customer? Like who are you selling it for? Like business entity customer, real end customer. things have to be, things were evolving, but they didn't take off. But it's AR specs form factor seems to be the right mix, right? Of use case, uh, utility-driven device. And now it'll boil down to what you run on device and what you run on cloud, various use cases. I'm generally excited about the possibilities it can bring in gateway live. But at the same time, care needs to be taken and it's done the right way. Like any video recordings happen dynamically. Like is it happening the right way? Like in your social setting, things like that. So assuming the utility as the utility gain balanced with the right societal expectations would make it powerful. But I think at this point, we all can agree that that's a nice computing form factor, which will come up with a high utility value in the near future.
Yeah, it'll be interesting to see what use cases. For me, like I see a lot of medical use cases and like surgeons using that as a
Mhm.
training tool, or obviously like military applications.
Right.
I mean, there's a lot of like those industrial applications, industrial engineers going out there, maybe looking at like defect, right? Of having the even like people trying to repair stuff. So I think I do see like a lot of interesting applications there. Consumer, it'll be interesting to see, right? What type of use cases
Yeah.
will drive adoption. Have you thought about that? Like what you're excited about in terms of what use case would drive adoption for consumers,
Yeah.
enterprises?
Yeah. So yeah, for sure. I given some thought to this. Like there's a business aspect and customer aspect, right? Like be interpreting this as a customer. uh, So the use case I explained, right? Like real-time translate, and I understand someone else's language, like image
Mm.
descriptions. Like I went to I'm touring a different state in India. Like I don't know what it's written. I can't understand the directions or an image on a signs. Can I do a translation for me? That the utility factor to me is high in that sense. And if I can real time ask a question, answer, get some questions, and get a factual answer for my questions, even better. Customers that I see value, but like for large scale adoption, the prices have to be low, the utility have to be high. Naturally, for enterprise cases, can like the use cases you mentioned, like for medical training, industrial inspections, right? Uh,
Mhm.
I think the device form factor need not be so miniaturized like in customer form factor. It can pack more sensors. You can pack more sensors. You can create better mixed reality headsets. You can your device can be more powerful, uh, and it can help also a targeted use case, the medical and military and industrial setting. But for sure, it will not scale, right? But for mass market adoption, for much larger utility, the miniaturization is a necessity in the path.
Yeah.
Gotcha.
I guess what do you see as the main blocker in getting to that next level? So for example, for that form factor to work, you have to have a really efficient battery pack, and then it's got to be very small, and you got to it have a modem that communicates very quickly with the network. And then there's a different approach where you're connecting via Bluetooth to maybe your phone, and then you're offloading all that compute to your phone. To get to that consumer use case that we all have in our mind, where you're wearing a very small form factor on your face, and then you're able to interact with your environment with augmented reality. What do we need to get over in order to make that a reality?
Right. So I think it all boils down to like engineering, optimization at the edge. But architecturally, it's like what do you want to offload to cloud? What do you want to offload to device? Um, but again, it's this helps, right? Like the more improved models also help. It's not like it's just a device thing, but improved models, better engineering to begin with, and hardware cycles are slow. We all can agree, right? Hardware cycles are slow. That's probably slowing things down. But yeah, as things progress, I think I'm pretty sure it will culminate to like a good utilitarian aspect. Yeah.
Yeah. I can see why you're so passionate about applied
For
AI,
sure. Yeah.
and making things
Right.
usable and easy for the consumer to use, as opposed to maybe theoretical, right?
Yeah, for sure.
Um,
In that thread, like there's also a selfish aspect of me trying to think about utility for myself, but that's a good, if you're developing something where you are also the customer, it helps. It only makes things better.
yeah.
I would love to learn about those patents, some of the research and the patents that you
Um,
previously published.
yeah. So few of my patents at Amazon, like, they're still work in progress, but during my tenure at Ticketmaster, like, I happened to work on like a real-time fraud block system with a great team. So at that point, like, conventional wisdom was like, oh, for fraudulent activities, to take them in real time, you think about it like, oh, how fraudulent is this IP address as a transaction is happening? Well, this situation was you're trying to, we're trying to detect fraud in like within a certain time budget. And we have some analysts reviewing it, like, for transactions where we are not confident, but where we don't know whether it's fraud or not fraud. Or it was an interesting team. Work with a great set of front-end engineers, data engineers, great managers. It was like all the entire team coming together. But at that point, the conventional wisdom was using a graph database for identifying fraud. Oh, is this fraudulent IP connected with a fraudulent credit card, which is in turn connected with a fraudulent email address? Like, all this connectivity patterns are best done via graph databases. But they're usually like their response time, query response time, are slower for graph databases. One of our data scientists at that point, James, like, he had did a pretty cool feature engineering pipeline where he translated this whole graph based features, like the features you care about from a graph. He translated that into a um, non-graph based setting, like tabular based setting with like first order, second order features, things like that. And then I took that to tabular translated features, and I build like a scalable Spark distributed distributed feature engineering pipeline. As well, that's on the offline side, as well as on the online side, we had some cool Kafka Streams applications powering, which understands this fraudulent first order, second order fraudulence, is like IP to email fraudulence, all things like that. And it was cool. Like, it was cool from a systems and modeling perspective, for reasons like using streaming applications instead of conventional uh, graph databases. That gave us like a boost in terms of real-time speed at which we can detect fraud. The other part, the other aspects are like we had our own like ranking models, classification models to cause whether a transaction is fraudulent or not, and the wherever transactions high confusion, like we were offloading them, like we were taking help from our analysts to review it. But it was cool. It was I'd say the most interesting thing to me is, well, like we moved pretty fast on that. Within a year, we were able to identify problems, solve it, deploy, get the gains. That was a big success at Ticketmaster at that point.
Interesting.
Wow, you developed that feature in a year?
Yeah, that was the cool part. Yep. When you know the problem you're working on, it's like things can move pretty fast.
And is that
Yeah, that's really
currently the
interesting.
is that the current standard right now in terms of how they manage fraud, is using that?
Things are always evolving. Like, I'm pretty sure graph databases query times have improved at this point. It's been like 5+ years. We did that. If I were to like revisit architecture, maybe there are more responsive graph databases at this point. Yes, architectural decisions keep changing, like, for sure, right? Like, every 2 years, 3 years, like, the platform you want to train, host models is rapidly changing. So it can be revisited, but that was one of the design factors. But at that point, we have a pretty good streaming culture at Ticketmaster back then. Kafka Stream was powering many applications.
I see.
Yeah, that's really interesting 'cause I think, it reminds me of like this study that Gartner put out, I think 4 years ago. It was something to the effect that 88% of AI projects fail to deliver for their executive sponsors, and that it would take from 12 to 24 months in order to come up with any sort of deliverable or some sort of outcome on an AI project. And it just kind of goes to show that the 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 industry has come very far in trying to focus for the problem or try to solve for a very focused problem using AI. Do you think that to be true?
For sure. Once a problem is well defined, once there's instrumentation pipelines for both measuring the problem and the, the data sets to power certain models, once the instrumentation exists, once you can measure where things are wrong, once you can A/B test that you're making the right change, yeah, you can go all in. Uh,
You make it sound so simple, but I'm sure it's not that simple, is it?
Right. Yeah, this problem. So at times it's not always about the problem, right? I might have posed this as like a prediction problem, fraud done, but reality is far from the truth. It's like, oh, if you have like n systems talking to each other, improving one system in the middle will make no difference if you're not looking at these n things. It's like, uh, uh, so at times you need to also zoom out, like forget about the problem you're working on, like zoom out and look out for everything around the problem. What are the impacts that what is everything that can impact it for the input side?
Yeah.
And what are all the downstream, what are you solving the problem for? What is the downstream ramifications? Like once you zoom out, right? Like maybe you need to solve that one to end problem and not improve the second component in this one to end chain. So at that point, at that point, I'll say we have great clarity, great managers, great team. Yeah. Which help us resolve.
Interesting. Yeah, thinking like thinking in terms of like a system, right? Versus, what they say seeing the forest, not the trees, right? Is a skill set that, I don't know, do you have a way to sort of help you do that in terms of like zooming out, as you mentioned? Like how do you
Like, I personally learned that skill at Amazon.
Hmm.
I used to be like very execution focused, very algorithm driven, like prior to my time at Amazon. Like let's just get this, let's just solve this problem. Let's see what others are doing, and let's compare certain architectural patterns and solve it. But the zoom out picture, I learned from my first team at Amazon. I happened to work on a cross border pricing team initially at Amazon, and that's when I'm really like, okay, zoom out helps. Had I zoomed in too much, I would be building wrong solutions. Yeah.
It's like, at Amazon, they say start from the customer, work
Customer
backwards, right?
backwards.
So that sort of helps you
Uh,
have that North Star.
Exactly. Yeah. But
I
then you talk
see.
about all, at least at that point, your known unknowns become clear. It's like, oh, I don't know anything about this, or I know about things. They become clear, like a question of unknown unknowns impacting your result. And having with a good team, I think you can possibly nail it.
I think you'd be a great product manager next. I mean, have you thought about being a product manager, leading new product initiatives with your technical, skill sets and that zoom out capability?
Right. No, not really, because there's another aspect of me who's interested in the scalability of things. Uh, uh, so these days, scalability infra side of things as well interests me, and sometimes my edge stays on looking at infra plus algorithm mixed initiatives, because that's one level of zoom out, right? Like, very few people can like go end to end. Like, for better or worse, I had that good opportunities along the way. So usually zoom out can only help if you're aware of the domain or problem. So usually domain understanding, problem understanding, time. And I worked on diverse problems along the way. So actually I lean on the product managers to learn domain, get a good, decent understanding, and then I go in with my broader end-to-end infra plus algorithmic innovations.
Hmm. I don't know. Maybe you'll come out with the next AR glasses. Mahesh, you'll be managing that product because you're invested in it. We'll call them good glasses.
Yeah, no, that would interest. But yeah, it's
Yeah.
a few more years out of the door. Yeah.
Yeah,
So
that's
I'm
great.
curious, how do you stay updated with this crazy, rapidly evolving technology? Like, do you read archive papers a lot? Do you sort of like follow other like NVIDIA scientists, working on some interesting solutions like at the edge, smaller models? Like, are you constantly doing a lot of research as well to maybe
Yes.
identify, better frameworks, better tools?
Right. So at least the frameworks that work for me, which I'm currently using, I would say is less of archives. I wouldn't say more of archive. It's actually less of archive. Uh, there are too many papers coming out, but the noise is also high. Like very few
Hmm.
things stand test of time. So mechanisms that's helping me are like Amazon internal science journals labs. They are great. Like different people go to different conferences and they present the summary of it, which is like a good gist. My own LinkedIn newsfeed community of like great science folks from across the companies. Next is like I've been like running few journal clubs. Like that happened to be like a good uh, learning opportunity for me, as well as learning about other domains. That has been the key thing for me all along.
Wait, you say you've been running your own general lab? What did you say? What kind of labs?
It's science journal clubs. It's just a group of people interested
Oh,
in like
cool.
within Amazon coming together, talking about a paper. And I got an opportunity to do the same at Ticketmaster as well. So that has been like for the last 10 years on and off. I was involved along the way. But its focus is not always papers. Focus is also on the great technical blogs that all companies put out. Uh, it's not necessarily papers. And naturally, these blogs uh, solve a problem and they go into an algorithmic setting, at which point we dive into the papers relevant to that problem. But yeah, blogs, summaries of conferences. At some time, like once in 1 to 2 years, I do attend a conference myself, all the popular conferences. This year, CUPR happened to be in Seattle. So I attended that computer vision conference. It was great. It was my first CUPR conference. So yeah, it's a mix of those. But I'll only go
Oh,
into
that's
where when it's related somewhat to what I'm working on at the moment, or some methodology which might help me.
oh, I love that, where you can get together with your peers and like if you look at the history of our human species, right? Like the Renaissance period, like where people meet like at a coffee shop or pub and they exchange ideas, right? I
Yep.
think that's been like even in like history of like all our scientists, right? They collaborated, right, in terms of knowledge sharing, and so that's what makes our species unique, right?
Yep.
Language and knowledge sharing. So
Totally.
that's instead of like being in a vacuum, right?
But for sure, like since I'm on the applied side, this might be my bias, but there are people on some theoretical side advancing like next generation models. Like they will have to dive into theory. Like obviously, I'm probably reaping in on the benefits of their work, but there are many such nuances. Like, yeah, yeah.
Besides all that, I'm always curious, like, what do you do for fun? Like, what other hobbies do you have, or is there hobbies thinking
Outdoors,
about this stuff?
outdoor sports is my thing. Like
Like, what's outdoor sports? Like,
tennis mostly, but more consistently, I'll be just running around and like the what do you say, like the hiking trails,
mhm.
whatever looks like a deep forest zone. If, as long as it's safe, I prefer literally running around there. Yeah,
Like trail running or hiking? Do you also do trail running?
trail running mostly.
Oh yeah, that's fun. Actually, I used to do trail run.
Yeah,
It's actually a rush, right? Like,
right, right. And
going
also you're in
downhill.
the more sometimes it's like a more scenic, nature centric. Yeah, we miss it quite a lot. Part impressed me a lot.
That's awesome. Are you part of the trail running clubs like in Seattle where you meet as a group and you know?
No. At this point, not enrolled in any club, but I live near University of Washington. A lot of parks around, and yeah, running. Like, there are actually good trails connecting the parks. That's more interesting from a nature perspective, actually.
That's
Awesome.
great.
I'm
Wow.
sure that gives you great
Mahesh,
ideas and
so
breakthroughs, right? When you run around nature.
Yeah.
getting more ideas. Thanks so much, Mahesh. When we finish and we finish with a podcast, we always like to ask our guests, for anybody listening who is interested in this field, in your example, applied AI. Do you have any advice for someone who wants to get into this field, someone who is interested in applied AI and wants to get in? And as you look back on the time that you have spent in this field, what kind of reflections and suggestions do you have?
Right. Yeah. For people entering the applied ML, applied AI field, I'll say it's more difficult than ever. First, I realize that it's more difficult than ever for freshers to enter the field. Competition is always growing. So one thing I've been at least prioritizing for myself was in learning aspect, seeking opportunities where I get to learn, I get to build something, possibly foregoing the things. I've been practicing that over last decade. What I realized is it's not just what you learn; it's also about the community you are in, because you can only learn so much. Things improve at an exponential rate. So prioritize the community as well. It can be in any form, like meeting, participating in some local meetup groups, or uh, be part of a community that you want, that is leading you in the direction you want it, wherever it is, the academic community, industrial community setting, conferences, or industrial conferences. So that's one aspect, if you have an opportunity to be that. And people try to, the other aspect is generalist versus specialist. Uh, so there are pros and cons of both. I'm a generalist. There there's certain things which I have to give up, but it also helps me have a broader picture. So figure out where you want to land in the specialist versus generalist zone, regardless of whether you're having a PhD or not. There are benefits to both. You can not make a case for both. See what fits you the best. And what I realized is as a generalist, things were not working in my favor earlier in my career, because I tried to be on infrastructure side, I tried to be on science side, I tried to be on data engineering side, and even within the problems I solve, I'm solving pricing problems, recommendation, ranking problems, and these days computer vision problems, like computer vision on the cloud, computer vision on the edge. It's like I'm going everywhere, which again perfectly fits me regard to where I want to be 10 years from now. But for a fresher, don't do it. Pick one area. Pick one area. Be part of a community. That community will give you the diversity you need, even if you have diverse interests. And once you feel like you're in the right place, branch out if your interest seems to be diverse. Yeah.
Wow, that's awesome advice.
Thank you. Well, Mahesh, oh man, our time is up. It went by so fast. It was so interesting to talk with you. Really appreciate your time today.
Thank you. Thanks for inviting again. Thanks, David. Thanks, Ken.
Take
Thanks so
care.
much, Mahesh. Have
Thank
a
you.
great weekend.
Yep.